Solve the inequality by graphing. Alright, so this first step to graphing this is basically we need to get this into a graphing friendly format. So we do that by completing the square, and that's going to put it into a format where you can easily pull out the vertex and the orientation of the parabola, things like that. So the first step to essentially completing the square is we're going to change this and put this, because we have a -1 right here, so we can essentially pull out a -1 from these first two terms here, and we'll be left with this, right? Now the next thing we want to do is we take this term, it's always the b term we can call it, where it just has one x attached, and we basically divide that in half and then square it. Okay, so that's going to give us 9, and then what we do is, it's a little math trick, we add 9 and subtract 9. So we're essentially not adding anything to this question, but by adding and subtracting 9 we can complete the square. So we continue on here, x squared plus 6x plus 9 minus 9 minus 9. So now what we want to do is we want to pull out this -9 and put it over here so that we have in this brackets something that is essentially just a squared term, right? So let's go ahead, and if we want to pull out -9, we have to multiply this -1 in so it can go out to the side there. So -1 times -9 is +9. So now, as we can see, these will cancel out and go to 0, and we'll just be left with this right here. Then we can realize that, well, x squared plus 6x plus 9 can be reduced down to x plus 3 squared, right? We basically use what we have right here and combine it with x. So we'll be left with, like I say, x plus 3 all squared. And now we have a friendly format where we can graph this a little bit easier. So as we can see, our vertex is going to be at -3 because we flipped this sign, and 0 because we don't have anything on the outside. So -3, 1, 2, 3. Right there, and 0. Now, the second thing we know is that it's going to be opening down, right? So it's going to be looking something like this, and that there's not going to be any vertical or horizontal compression. So we're essentially just going to be writing a regular parabola, but upside down. So it's going to go over 1, down 1. In fact, I'll make that just a bit more accurate. So over 1, down 1, and then over 1 and down 2, and so on. All right. Now the last thing we need to do is figure out where to shade. Now there's two ways to do this. There's one really easy way that I recommend learning, and that's basically just by looking at our initial inequality here. So we're trying to solve for y, which is less than this parabola given, less than or equal to, which essentially means we're going to want to shade where the graph is less than the line. So if we can assume that this parabola goes to infinity, then the only places that are less than the line are basically within the parabola, right? But we can also do a test point if we want to, just to kind of prove this method. And so let's do a test point at 0, 0, which is outside the parabola. So test. Okay, so we're basically just going to plug 0, 0 in for right here. So we'll have 0 equals negative 0 minus 6 times 0 minus 9. Sorry, this should be a inequality sign. And so we basically have that negative 9 is going to be greater than or equal to 0, which obviously isn't true. It's less than. So that means that since the test point is outside here, that we're going to pick inside, right? Because we have a false statement. Had this been a true statement, we would have had to shade on the outside. And as you can see, had this sign been flipped the other way, we would have shaded on the outside, which is in line with our initial way of solving it, where we look at the inequality sign. Okay, so either way it works to find which area to shade, and that is all for this question. So I hope that helps. Thank you. Bye.